At our today's class. Okay, so hello everyone. This is lecture 5 on discrete mathematics, and in this lecture we are going to resume our previous lecture only. And in the previous lecture we were discussing for all is not distributive over implication. Proof was this which I have given you. Now question arises which way it will work. Okay, so let me copy it. Yes, so obviously both ways it is false. Okay, both ways it's not working. So now my question is this correct? That means if we move from left to right, is it okay or not? So let me check it out. So again, same scenario. Okay, so if we consider that this entire formula is true, okay, if we consider that this entire formula is true, then we should not be able to make this as true and this as false. Okay, if we by chance we are able to make this as true, this as false, I will immediately say okay, this formula is not valid or it is not tautology and so on. Okay, so let me do it. So we will try to make this as true and this as false. Okay, so first of all we should expand it now. Okay, without expanding, how we can check? So P1 implies Q1 and P2 implies Q2. I have told you many times, if you know how to expand it, almost most of the work is over. Okay, so P1 implies Q1 and P2 implies Q2. This implies P1 and P2 implies Q1 and Q2. Okay, so let me try to make this entire thing as true and this entire thing as false. Okay, so how we will make it, let me show you. Yes, so we want to make this thing true and this thing false. So now see, there are two ways. We can start from here or we can start from here. If we start from here, that means we want to make this as true. So to make this as true, only one possibility, this should be true and this should be true. Okay, and if we want to make this as false, only one possibility, this should be true and this should be false. Okay, so both ways I can start. It's my way, so you can start from any way. So let me start from here. Okay, so I will try to make this as true and this is false. Now in order to make this as true, this entire thing as true, I should take P1 as true, P2 as true. Okay, yeah, so immediately I will come back here and I will make P1 as true, P2 as true. Now I will take this side. Okay, so it's our way na, so whatever way you want you can do. Okay, and we should apply the shortcut, whatever shortcut you are thinking, that will be fine. Okay, so now I have applied the values. Now I will try to say okay, I will make this as true. In order to make this as true, this should be true as well as this should be true. So directly these two cannot be false now, so directly both should be true. So now my conclusion is Q1 should be true and Q2 should be true. Now the moment I say Q1 and Q2 are true, immediately I will say this is true, this is true. So obviously true and true will be what? True, true and true will be true. So true implies true will be true. So I cannot make it as false. So when this is true, this cannot be false. So obviously this formula is valid formula. Okay. So I hope you have got it. Please take snapshot. I will jump to the next slide. Okay, so now obviously, okay, yes, I hope you have taken the snapshot. Yes, so now obviously in the previous slide we have seen that this formula is false. Since this is false and I am saying that this is true, so obviously this direction will be false. Okay, so let me show you. If so now immediately I will say, okay, immediately I will say that this side will be false. 100% this side should be false. Why? Because if this side is true and this side is also true, then obviously this double implication should be true, na? But I have told you double implication is false. So obviously when this is true, this 100% this side should be false. Okay, but let me prove it, why this is false and all. Okay, yes, so same scenario. Okay, what should be our, so first of all expand it and then we will show. So expansion will be P1 implies Q1 and P2 implies Q2. I think I should not give reason why this and is coming, because of this for all. Okay, so P1 implies Q1, P2 implies Q2, and is there because of for all. And I have told you many times we will expand it only 2 times. That is more than sufficient. Okay, so now what will be this? P1 and P2 implies Q1 and Q2. Okay, yes. So now I want to make this entire thing as true and this entire thing as false. So if I got the success in making this, then I will immediately say that the formula is not valid. But if I do not get success, then I will say formula is valid. Okay, anyhow, I have told you that we will definitely get success, but let me show you how we will get it in the gate exam. Obviously we will not by heart all these things now, that this double implication is false, this is true. Only then you can be able to say that this is false without expanding. But we do not we are not by hearting anything. So better is try to follow these rules. Okay, make this as true and make this as false. Okay, to make this as true, what should be done? See, there are to make this as true, there are 3 ways. Okay, why? Because this can be true, this can be true, this can be true, false, this can be true, this can be false, this can be false, and so on. So there are 3 ways. Okay, so we will leave it. Okay, we will not dig deep into it because it will waste our time. There are 3 ways of doing it. Okay, similarly if we see this thing, to make this as false also there are 3 ways. Okay, are you getting it? There are 3 ways to make, because this is false, this is true, or this is false, this is true, or both are false. There are 3 ways. So we are stuck. So we can start with any way. The only thing is we have to save our efforts. Okay, yes. So what should be done now? Okay, from where we can start? Okay, so let me start from here to make this as false. So to make this as false, I have to make any one of them as false. Okay, so I have told you many times, minimum effort we should do. So one should be false and one should be true, like this we have to do. Okay, so anyhow, let me start. So I am trying to make this as true. Okay, this is true and this is false. Now immediately when P1 is true, Q1 is false, you will immediately come here and make this as true and this is false, and try to see any conclusion. Can we make any conclusion? Now since we want to make this as true, now this is true and this is false, I have already done. So now I will forget about Q2. Q2 can be either true or false, it hardly matters to me. This entire thing will be false. Now since this entire thing is false and I want to make this as true, so the only possibility left is I have to make this as false. Okay, because if I make this as true and this as false, obviously true implies false, it will become false, but I want to make this as true. So clearly I have to make this entire thing as false. So the only possibility is P2 should be false. P2 cannot be true, P2 should be false. Now as soon as P2 become false, I will come here and I will make it as false. Now as soon as I make P2 as false, so now I will forget about Q2. Q2 can be either true or false, it hardly matters to me. This entire thing, see, this is false, okay, and this will be true. Okay, why? Because why this will be true? Because P2 is false now. Since P2 is false, so Q2 can be the true or false, it hardly matters to me. This entire thing will be true. Now false and true is false only, so I have made it as false. And now since this entire thing is false, so false implies false, this is true, so I have made this as true and this as false. I have got this success. So finally I will say it is not valid formula. If anybody is having any doubt, please let me know. Otherwise I will jump to the next slide and start the next question. Okay, so I hope it's clear to everybody. Please take snapshot. If anybody is having any doubt, please let me know. Okay, so I'm jumping to next slide now. Okay, so now see this, we have done this. So now with there exists, we have to see. Okay, there exists an implication. Okay, so let me show you. So there exists X, Px implies Qx. First we have to see this thing, is it equivalent to there exists X Px implies there exists X Qx. Is it equivalent? If it is equivalent, then question is over. Okay, we will not dig deep into it, and I will obviously say this side also, both will be true. Okay, so let me check it out if double implication is working here or not. So first of all, I will expand it. So what I will say, P1 implies Q1 or P2 implies Q2. Okay, Now is it equivalent to saying as P1 or P2 implies Q1 or Q2? Let me check it out. So double implication is very easy, na? So you just expand by Boolean algebra, you will get the answer. So what I will say, P1 bar plus Q1 plus में P2 bar plus में Q2. Okay, I am getting this thing. Now is it equivalent to saying as P1 plus P2 whole bar plus में Q1 plus में Q2? So what it will be coming? P1 bar dot P2 bar. Okay, plus में Q1 plus में Q2. So obviously they are not coming to be equivalent. Okay, because Q1 and Q2 are okay, no problem. Q1 plus Q2, here also Q1 plus Q2, but here P1 dot P2 and here P1 plus P2. Okay, P1 bar plus P2 bar and here P1 bar dot P2 bar. So obviously they are not equivalent. Okay, so now I have to check the direction. So the only way is I have to check the direction. Okay, so let me show you how we will do it. Let me copy it. Okay, so now we will try to find this way. Okay, so what should be done now? Same thing, expanding. So P1 implies Q1 or P2 implies Q2. This implies P1 or P2 implies Q1 or Q2. Okay, yes. So now what should be done now? So I have to make this as true and this as false. If I got success in doing this, then I will immediately say that formula is not valid, otherwise it will be valid. Okay, so how we will check it out? So this is true and this is false now. So in order to make this as false, there are three possibility. Sorry, only one possibility. Sorry for that. For to make this as false, there is only one possibility. So this should be true and this should be false. And in order to make this as true, there are three possibilities. Okay, so obviously which one is better? Only one possibility thing is better. Okay, because here we have three possibilities. So are you getting it? Here we have three possibility to make this as true, because this can be true, this can be false, this can be true, this can be false, both can be true. So there are three possibility for it, but here only one possibility. That means this should be true and this should be false. So this is much better or much easier task for us. So let me do that. Okay, now so yeah, so to make this as true and I have to make this as false. So to make this as false, so now I will again see, to make this as true, three possibility. Okay, P1 can be true, P2 can be false, P2 can be true, P1 can be false, or both can be true. Okay, so and here only one possibility, so better is this one. So only one possibility, that means Q1 should be false, Q2 should be false. Immediately you will come here, Q1 should be false, Q2 should be false. Now what I will say now, and I have to make this thing as true. This thing as true means what? Minimum I will do, try to do minimum task. This is true and this should be false, both should be true. I should not do this. I have told you many times, minimum task you have to do. So minimum possibility, this should be true, this should be false. Okay, so P1 true, P2 false. Immediately I will say P1 is true, P2 is false. So now what I will get immediately, you can see true implies false is what? False. But false implies false is true. True or false is true. I have got this thing as true and I have got this thing as false. I have got this success. So obviously this formula is not valid. This formula is not valid. Okay. Now let me check the other way around. Okay, now please do not say like this, that this formula was invalid, this formula was invalid, and this is coming to invalid, so obviously this direction should be valid. No, 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 I have not said this. If by chance this become valid, then I will say this is invalid. Are you getting it? If by chance this is valid, then I will say this will be invalid. Why? Because double implication is invalid. Okay, now since double implication is invalid, so there are possibility that both are invalid. Okay, so I have to check that. I think it's obvious. If anybody is having any doubt, you can let me know. Otherwise, I will jump to the next slide and I will try to see what happens for the other way around. Okay.
Done, sir.
Okay then. Okay, I'm jumping to the next slide. Okay, so next slide is not there. So let me take it. Yes. Okay, so now what should be done? So I will expand this way. Okay, so now same thing. So first of all, I will expand it. Rather, I should. Okay, let me do it one more time. No problem. So P1 or P2 implies Q1 or Q2. This should imply what? P1 implies Q1 or P2 implies Q2. Okay. So now this implies this I have to do. So again, same scenario. I have to make this as true and this as false. So let me try it. Now in order to make this as true, okay, so minimum possible work. What should be the minimum possible work? To make this as true, there are three possibility obviously. To make this as false, again there are three possibility. Okay, because sorry, one possibility only. To make this as false, only one possibility, because both should be false. Okay, both should be false. Okay. So obviously this is much better. This is not better. Why? Because I have to consider three possibility and here only one possibility. So obviously this is better. Okay. So what should be done now? So I have to make this as false also, this as false. Only then I will say false or false is false. Finally we will get it. So now to make this as false, only one possibility, but this should be true and this should be false. To make this as false, only one possibility, this is true, this is false. So this is a very easy task. Now P1 true, P2 true, true or true, and Q1 is false, Q2 as false. False or false is false. True or true is true. True implies false is obviously false. Okay, I'm not getting this as true. Okay, so as soon as I make it as false, this should be false. So obviously false implies false, true only. So directly indirectly, I am not able to make this as true and this as false. So obviously this is a valid formula. Okay, because making this as false, only one possibility was there. Okay, making this as false is only one possibility, and I have considered that. And while considering that possibility, this is not we are not able to make this as true. This should be false only. So directly and indirectly, this is valid formula. Okay, please take snapshot. I will jump to the next slide now. Okay, so yeah, and okay, I'm jumping now. So before starting this gate question, let me show you one more thing. Okay, yes. So the summary of this lecture, the things which we have done is summary is we have to remember two golden rules. Two golden rules. The very first golden rule is P implies Q. If this is the case and I want to make this as false, or I want to check whether this is valid or not, so just try to make this as true and this is false. If you got this success, immediately you will say formula is invalid. Okay, if no success, if you are not able to get success, then you will say it is a valid formula. That is the simple rule which I have used again and again. And the second is you should know how to do expansion. If you know how to do expansion and you know both first and second rule, you can solve any gate question. Okay, you can solve any gate question. Whatever gate question will come, you will be able to solve it. This was the summary. Please take snapshot. Now I will jump to the gate question now. Okay, so I'm jumping now. So this is gate 2020 question, and they are saying whether this is valid or not. So again, this is very simple task. We should know the expansion. If we know expansion, we can do it easily. Now there is a twist in this gate 2020 question. The twist is that here for all x, here px, but here qx is not there. Ideally we should have qx. Now in all the questions which we have done so far, so everywhere px qx, everywhere see this px qx, previous slide px qx, everywhere there was like this. Okay, so in gate 2020 there was a twist. And what is the twist? Px implies q was given, qx was not given, only q was given. So and there is no information about q, so you just treat it as a black box. I do not know what is inside it and all. You simply take it as q only. So while expansion, the only thing is expansion. If you know expansion, everything is over. So what we will do, I will say like this: P1 implies Q and P2 implies Q only, both. So I will not apply Q1, Q2 and all. Why I'm not applying? Because here x is not given. When x was given, then I will say na px. So I will expand it like px1 and then px2, and my shortcut was px1 is written as p1, px2 is written as p2, and so on. So now there is no x and all. So obviously I will treat it as a single q only. Okay, treat it as a black box. So p1 implies q and p2 implies q. This is the thing which you should remember. Implies there exists x, px implies q. Now p1 implies q or p2 implies q. That is the scenario. Okay, so we have to check this out. Are you getting it now? Yes. So now it's very easy. So now we can do it on a very simple manner. See, here same thing is there, na? Same thing, and here also same. But here we have and here we have or. So I think you remember all these things. Whenever and is true, then obviously or should be true, na? Because what and will say? And will say both p and q should be true, and or will say at least one of them is true. So obviously when and is true, or should be true. That is very obvious. Directly indirectly I want to say this is true, this is false. It is never possible, na? When and is true and or should be false, that is never possible. So obviously and implies or, that is always true. Okay, this is a valid thing. So same scenario. Here is and, here is or. Immediately I will say this is a valid formula. Are you getting it? If you have still any kind of doubt, you can solve it by the shortcut which I have told you. So try to make this as true and this as false. So you will never be able to make it. Why? Because in order to make this as false, you have to make this as false as well as this as false. Now to make this as false, you will consider p1 to be true, q should be false, and p2 should be true, q should be false. Okay, and immediately whenever you come here, p is true, q is p1 is true, q is false, p1 is true, q is false, immediately it will become false. Okay, so I hope I have made the point clear. So you will never be able to make this as true and this is false. So directly I have written a valid formula. Why it was valid? Because and implies or, that is always true. Okay, and implies or is true, because whenever and is true, or must be true. Okay, we cannot find a case where and is true but or is false. I hope I have made the point clear. Please take snapshot. I will jump to the next slide now. Okay, I'm jumping now. So similarly, if I say like this, for all x, px and q, is it equivalent to for all x, px and q? Okay, so let me check it out. Okay, so directly indirectly, see, this is very basic thing. Okay, sometimes this type of question have been asked in GATE. So directly indirectly, implication na. So I will try to apply Boolean algebra and try to solve. Sorry, double implication. Double implication means equivalence. Equivalence means I will apply Boolean algebra and try to solve it very easily. So let me expand it. So for all x, px and q, so I will say p1 and q and p2 and q. That's it, because q here qx is not there, na? Only q is there, so I will treat it as black box. So p1 and q and p2 and q. What about this scenario? p1 and p2 and q. Okay, so now I think you already know. So p1 and p2. Okay, and q will be what? Q only. Okay, yes, so idempotent law you already know. Q and q will be q only, and here also p1 and p2 and q, so both are equivalent. So that's it. And it, by common sense, you can also see now for all x, px and q. So you are extending the scope of x to q also, but there is no need to extend till q now, because q is not having any x. Q is a black box. So obviously I can remove this bracket also, and as soon as I remove this bracket, I will get this thing. So obviously they should be equivalent. Okay, like this, there are hell lot of questions. Okay, from morning I will keep on solving the question until night. I can solve lots and lots of questions, but it is no use for all of you till once you do the practice of all these things, you will get more clarity. So my request is now solve all the pyqs. You will be able to solve each and every pyq. Okay, yes, now please take snapshot. I will jump to the next slide. Okay, yes, I'm jumping now. Yeah, so I have already explained you the golden rules. Okay, yes, I'm jumping. So now we will start predicate translations. This is also very important topic. Many times questions have been asked in GATE from this topic only. And many students feel that this is a confusing topic, but no, it is not confusing. If your concepts are clear, if you are able to listen my lecture very very carefully, then each and every gate question you will be able to solve. This is my guarantee to you. Okay, so try to focus here. Some of you might get confused somewhere, so as soon as you find any kind of confusion, please immediately let me know. I will stop and I will answer your doubt. Okay, try to focus here. So Cx is given as X has studied calculus, and domain is given as all the students in the class. So try to focus at the domain. Domain is all students in class. Now I have told you many times, if domain is missing, you will consider it as a entire universe. And if you are talking about numbers, domain is missing, then you will consider it as a real number. I have told you in the previous lecture itself. Okay, there are many times I have told you. Okay. So now we will start. Question number 1 is, every student in the class has studied calculus. So I think it's very very obvious. Every student in the class has studied calculus. So for all x, Cx. That's it. Okay. For all x, Cx. Okay, let me write it properly. For all x, Cx. Okay, so every student in the class has studied calculus. That means domain is all student in the class now. So this is the class. So every student has studied calculus. So for every element, this should be true now. So that is nothing but for all x, Cx. Very simple. Next is, some student in the class has studied calculus. Some student in the class has studied calculus means there exists x. There exists x, Cx. I think you have got it. Please take snapshot. I will jump to the next slide. This is very simple. Okay, so I hope you have taken it. Next is, Cx is X has studied calculus. Same question. Sx is X is student in the class, but now domain is entire universe. In the previous question, domain was what? All students in the class. But now domain is entire universe, and two things are given to you. Cx is X has studied calculus. Sx is X is student in the class. So please tell me, what do you mean by this? For all x, Cx. In the previous formula, we have written for all x, Cx. What does this mean? Every student in the class has studied calculus. Why I'm saying every student? Because domain of x, domain was set to all the students in the class. So obviously I will say every student in the class has studied calculus. So now please tell me, domain is entire universe. So what do you mean by for all x, Cx? It means everything in this universe has studied calculus. Everything in this universe means your laptop, your mobile, okay, your TV, everything has studied calculus. And clearly this is meaningless thing. Okay, whatever thing you can imagine in this universe, everything has studied calculus. Clearly this is meaningless thing. Okay, how your TV, how your laptop will study calculus? That is impossible. Okay, so now the question arises, every student in the class has studied calculus. Now please try to focus here how you will write this in logic. Okay, if you are able to understand this, then directly indirectly you will be able to understand each and everything after this slide. If you are doubtful here, then in each and every coming slide you will be doubtful. So please try to focus here. Every student in the class has studied calculus. How you will show? First possibility was for all x, Cx. It is clearly wrong. So now what should I do? I will say, see, domain is entire universe. So this is my entire universe. In this universe, there is a small part which is what? Your class. Okay, so this is the entire universe. This is the entire universe, and in this entire universe there is a small part. There is a small part which is your class. Okay, this is your class. So now I will say, if somebody is here, that means if somebody or if some student is there in your class, then he or she must have studied calculus. That is the meaning of the statement. Every student in the class has studied calculus. So first of all, you will restrict the domain. That means first of all you will check whether the student is in your class or not. Like for example here, this is not your student, so you cannot apply restriction on it. But if you are here, that means if somebody is in your class, then you will apply restriction that he or she must have studied calculus. So directly and directly I will say, if X is a student in your class, then he must have studied calculus. This is the meaning of the first question. Are you getting it? So meaning of the first question is, if X is student in your class, then X must have studied calculus. That is the basic rule. So now I will say for all x. Why for all? Because every. For all x, I will say if x is a student, then he must have studied calculus. I think you have got it. So I will say if x is a student, then he or she must have studied calculus. So for every x, if x is a student. So now there is a condition. If x is a student, then he or she must have studied calculus. But if x is not a student, then no problem. Okay, so now I will say everything in this universe. Please try to focus here. But I will say x is what? For all x, x is what? Domain is what? Entire universe. So everything in this universe, if x for every x in this universe, if x is a student in your class, then x must have studied calculus. So if I am talking about this person, this fellow is not in your class, so he or she may or may not have studied calculus. It hardly matters to me, because your sx will be false, because sx is what? X is student in your class. So when I'm talking about this is not sx, okay, because it is not student in your class. So for this, he may have studied calculus, he may not have studied calculus, it hardly matters to me. Same thing if sx is false, then cx may be true or false, it hardly matters to me. Okay, when sx is false, then cx may be true or false, it hardly matters to me. But when sx is true, then cx must be true. Okay, because when sx is false, okay, when sx is sorry when sx is true and cx is false, then I will say implication is false so obviously I have given this restriction. Okay, so for every x, I will say for every x, this entire formula will be true. This entire formula will be true for every x. You can check it out, because sx is true, cx is false is not possible. Okay, because I have written this thing every student in the class has studied calculus. So for all s, sx implies cx. I hope you have got it. I have explained it in a very simple and easy manner. Okay, so let me start the second question. Some student in class has studied calculus. Some student. So there should be some student in your class who have studied the calculus. So some student means what? There exists x. Okay, now what should I write? Now what should I write here what should I write? So you may be thinking like this, sx implies cx. No, I will not write like this. Why? Because this means there exists something in this universe. If he or she is a student in your class, then he or she might have studied calculus, or he should have studied calculus. So this is completely meaningless thing So for example, I will say like this, if sx is false and cx is true, so this entire formula will be trivially true So I will consider this thing. Say this is your laptop, and you will say my laptop has not studied calculus. So immediately your this entire formula will become true. Are you getting it? Your this entire formula will become true. Why this entire formula will become true? Because it is saying there exists x. So there should be at least one x for which this entire formula should be true, and I have found a x for which this entire formula is true. So obviously I have got it, and I will say okay. Okay, so clearly this is meaningless. Clearly this is meaningless. Okay, and why this was meaningful? Because for every x, this entire formula should be true, and I have shown you clearly that for each and every x in this universe, this entire formula will be true. Because if something is not in your class, then trivially this formula will be true. But if something is there in your class, then then he or she should have, or rather must have studied calculus. Okay, if something is there in your class, then he or she might have studied calculus. Something means student. So if x is a student in your class, then he or she must have studied calculus. So for all x it is saying so that means this formula should be true for every x, and I have told you that this formula is true for every x. Now there exists x means what? This formula should be true for at least one element, at least one thing in this universe, for at least one thing in this universe, this formula should be true. And I have proved you when Sx is false, Cx is true, this formula is clearly trivially true. This formula will be trivially true. And I have taken any element in which is outside your class, and I will say that it is a laptop, and obviously it has not studied calculus. It hardly matters to me. Immediately I will say this entire formula will be true. So obviously this entire formula is meaningless. So what should be done? What should be done now? So let me show you now. So I will say there exists X. Okay, if something in this universe, if something is there in the, everything, something is there in the universe. Matlab, there should be something in this universe who is a student in your class and he must have studied calculus. So and will be there. Okay, so now I will tell you a golden rule which you should remember. What is the golden rule? What is the golden rule? With implication for all, for all, implication is meaningful. With there exist and is meaningful. Okay, with there exist and is meaningful, and with for all, implication is meaningful. I hope everything is crystal clear to everybody now. Okay, with for all, the implication, and with there exist and. Okay, yes, with for all, and sometimes it will be meaningful. I will tell you all these things, but with there exist, implication is never meaningful. Let me write it. With there exist, implication never meaningful, but for all and it will be sometimes meaningful. I will tell you those cases also when with for all and is meaningful, but here it is not meaningful. Like I will say like this: for all x, sx and cx. How you will read it? Everything in this universe is student in your class and he has studied calculus. So everything in this universe, that means your class is everything in this universe. That is clearly meaningless, na? Your laptop is also in your class. Your computer is also in your class. Somebody sitting in US and he is having some mobile phone, that is also there in your class. That is clearly meaningless thing. Okay, so it is not the case. So here it is meaningless, but I will show you some places where it will be meaningful. Here it is meaningless because are you able to read it? Everything in this universe should be student in your class and he must have studied calculus. Clearly it is meaningless. Okay, so I hope I have made the point clear. And some student in class has studied calculus, so there exists x, sx and cx. Okay. Yes, so he must be student and he must have studied calculus. Okay, now. So this is the rule. Okay, so the thumb rule is this thing. For all, with for all, implication is meaningful, there exists and is meaningful. And when we will use all these kinds of things, this is also very, very important. Let me write it with a blue color. When we will use all these things, when we have a big domain, we have a big domain, and we are talking about, or we are concerned with small domain or subset of this domain, and we are concerned with subset of this domain. Are you getting it? We have a very big domain, entire universe, and we are interested in a very small domain, that is the student, that is the class. Okay, x is student in your class and x has studied calculus, so we are interested in class, your class. Okay, so entire universe and we are interested in your class only. So whenever we have a big domain and we are concerned with subset of this domain, then we will use all these kinds of things. Okay, now please take snapshot. I will jump to the next slide. Okay, and I will show you few more questions. Don't worry, if you have any doubt, each and every doubt will be solved once we will do the practice questions. Okay, practice is the key to success. We will practice lot. Okay, let me jump to the next slide now. I'm jumping now. Yes. So next is a domain is all cars on the expressway. Fx is x is fast, dx is x is dangerous. So the question is, every fast car on expressway is dangerous. Every means for all x. Now see, this domain is all cars on the expressway. And what we are saying is every fast car on expressway is dangerous. I'm not saying every car on expressway is dangerous. When every car on expressway is dangerous, that means we are talking about this entire domain. But I'm saying every fast car on expressway is dangerous. So that means what I want to say, it should be a fast car. Okay, so I will say if X is for all X, that means for every car on the expressway, if that car is fast, then it will become dangerous. So that means what? Fx implies dx. I think you have got it. So this is the way. Okay, and same thing I have already told you, na, all cars on the expressway, and we are concerned with a very small subset, which is the fast cars on the expressway. I'm not concerned with all the cars. I'm concerned with the fast cars only. So from big domain, I'm interested in a small domain or its subset. From the big domain, I'm interested in its subset, or I'm interested in a small domain. That's it. Okay. So what about this next question? There is some fast car on expressway which is dangerous. So what do you mean by this? There is some fast car on the expressway. So there is at least one car on the expressway which is dangerous. Okay. So how you will write it? Obviously there exists x, some na, there exists x. Immediately without thinking, I have told you, you will write fx and dx, because with there exist and is meaningful, and with for all implication is meaningful whenever we are talking about a small domain. But we have a big domain and we are talking about small domain. So in that scenario, with for all implication, with there exist and. So there is some fast car on expressway which is dangerous. I will talk about, I will say there is some car on expressway which is fast as well as dangerous, or which is fast and dangerous. One and the same thing, no? So I will say that there exists car on the expressway, or there exists at least one car. There exists car on expressway which is fast and dangerous. So please try to think about it. This statement and this statement are equivalent, na? There is some fast car on expressway which is dangerous, or there is just a car on expressway which is fast and dangerous. One and the same thing only. Okay. So and when I have written this statement, you have immediately guessed that this is the way to write it in logic. Okay. Please take snapshot. I will jump to the next slide now. Okay, I'm jumping now. So the question is, every fast car is dangerous or every dangerous car is fast? Are these two same? The question is this. Same thing is given. Domain is all cars on expressway. Fx is fast, dx is dangerous. Let me copy it. If you have doubt, let me copy it. So same thing. Okay. So for this question, this thing is given to you. Domain is all cars on expressway. Fx is x is fast, dx is x is dangerous. So are these two statements equivalent? Every fast car is dangerous and every dangerous car is fast. Okay, you may be thinking both are equivalent, but no. Try to think in the terms of logic. So how you will expand it? For all x, if x is fast, then it is dangerous. If x is fast, then it is dangerous. How you will expand it? For all x, if x is dangerous, then it is fast. And you already know p implies q, q implies p, they are not equivalent. Okay, because this is direct and this is converse. They are not equivalent. So obviously they are not equivalent. Every fast car is dangerous and every dangerous car is fast. They are not equivalent. Dangerous may be like some dangerous personality is there in the car. Okay, some you can say some thief and all kind of things are there. Some antisocial element is there in the car. Then obviously it will become dangerous. It hardly matters it is fast or not fast. Some slow moving car may be dangerous because some antisocial element is there in the car, and so on. Okay, so every fast car is dangerous is this thing, and every dangerous car is fast is this thing. Okay, so directly and indirectly, see, if you want to dig deep into the topic, I will say like this: every fast car is dangerous means, so if car is a fast, if car is moving very fast, then obviously you will say it is a dangerous. Okay, yeah. And what this is saying, if this is a dangerous car, no matter it is moving fast or slow, you will immediately say it is fast. Okay, so if the okay, let me write it again if you have any doubt. What I will say, if the car is dangerous, if the car is dangerous, immediately you will say it is a fast. Okay, and what is saying, if the car is moving very fast, immediately you will say it as dangerous. So obviously they are not equivalent. Please try to think about it, you will get more clarity. Okay, yes, please take snapshot. I will jump to the next slide now. Yes, I'm jumping now. So next is domain is entire universe. Okay, so they might not give this also. If this is not given, by default you will consider it as entire universe only. I have told you many times. Fx is x is fast, dx is x is dangerous. Now see this. Previously domain was all cars on the expressway. See this. All cars on the expressway was the domain, and fx was x is fast and dx was x is dangerous. But now I have changed the domain. Earlier domain was all cars on the expressway, but now domain is entire universe, and now I am saying fx x is fast, dx x is dangerous, cx is x is car on the expressway. Okay, so now domain is entire universe. So first of all you have to concentrate on the cars on the expressway. That means you have to concentrate on its small subset, that is cars on the expressway. So you are concentrating on cx. So now I will say every fast car on expressway is dangerous. Every means for all x. So now you will immediately say, if the x is car on the expressway, then I will say na. So I will say for all x cx implies. Now what I will say, every fast car on expressway is dangerous. Then I will say, if x is fast, then it should be dangerous, like this. Okay, so now please see this. This is an invalid sentence which I have written. Okay, why this is invalid? Because I have told you, see, if you try to remember my previous classes, p implies q implies r. Implication is not associative. That means this is not equivalent to this. I have told you many times, when these two are not equivalent, so how you can write this thing? This is not valid, this is invalid thing. Okay, this is rather meaningless, because I do not know where is the brackets and all. Okay, are you getting it? See, if I write, I have told, just consider mathematics. If I write 2 plus 3 plus 4, you will say, okay, it hardly matters to me whether you do 2 plus 3 or you do 3 plus 4, it hardly matters to me. So it is valid thing. But if I say 2 minus 3 minus 4, this is invalid. Why? Because 2 minus 3 minus 4 and 2 minus 3 minus 4, they are giving us different answers. So what exactly do you mean by this? This is ambiguous thing, because it is having two meanings. Okay, so immediately you have got it, that p implies q implies r. Writing this is invalid. Why? Because what do you mean by this thing? Either this or this. Okay, so I think you have got it. So now what should we do now? So if we should apply a bracket here like this, or we should apply a bracket like this. Okay, so now let me tell you both the things. Okay, let me clear you both the things. So first of all, I will say like this. I will say like this. What do you mean by p implies q? In terms of set theory, I have told you, when p is true, then q must be true. Na? That means what? P is subset of q, like this. So now if I am talking about cx implies fx, like this. What do you mean by this? Cx is inside and fx is outside. What do you mean by this? That if x is a car on expressway, then it must be fast. So if I apply brackets like this, then what do you mean by this? Everything in this universe, if x is a car on expressway, then it must be a fast car and it should be dangerous. So clearly this is meaningless thing. Are you getting it? Everything in this universe, if x is a car on the expressway, then it must be fast car. So that means you want to say that every car on the expressway is fast. How you can say like this, every car on the expressway is fast, and you are saying like and you are saying that it is dangerous also. It is meaningless thing. We should not apply bracket like this. So other way should be, I will apply bracket. Let me copy it. Okay, let me write it again. Copying will waste our time. So yeah, I will write here, for all x, cx implies fx implies dx. I will write like this. What do you mean by this? For all x, if x is a car on expressway, then if x is fast, then it should be dangerous. So clearly you have got it. Every fast car on expressway is dangerous. Are you getting it now? I am saying every car, everything in this universe. For all x means, first of all, you should say like this: everything in this universe. If x is a car, then if then na, if x is a car, then if it is a fast, then it should be dangerous. Clearly, this is the good way. Okay. So yeah. So answer to the first question is this. This is not the answer for the first question. This is the answer for the first question. I think I have cleared everybody doubt now. So this is clearly meaningless. Everything in this universe, if x is a car, then it should be fast and it should be dangerous. It is not the good case. Rather, it is meaningless thing. Every car on expressway is fast. If every car on the, rather I should say like this. If you want me to write this in English, I will write like this. What is the meaning of this? Everything in this universe, everything in this universe, if everything in this universe, if everything in this universe, if what should I say? Actually, the English problem I'm facing. English problem. What should I say? Okay. If every car on the expressway is fast, then it should be dangerous. If every car on expressway, if every car on expressway is fast, then it will be dangerous. Then it will be dangerous. Are you getting it? This means if every car on expressway is fast, then it will be dangerous. Every car on expressway, if every car on expressway is fast, then it will be dangerous. Cx implies fx. I have told you this thing. Cx is here and fx should be there. So every car should be fast. So now see this. I have told you every car should be fast. Now see this. So now take it as one black box. Treat it as a black box, and I have this thing. So now you see P implies Q thing I am having. So P is what? Every car is fast on the expressway. So I will say if every car on expressway is fast, then it will become dangerous. Okay, so clearly it is meaningless thing. Anyway, I should not waste time here. Let me jump to the next question. I think everybody have got it, and this is clearly good thing. Everything in this universe, if X is a car, then if X is fast, then it should be dangerous. Okay, for every X in this universe, if X is a car, okay, let me write it. For every X in this universe, for every X in universe, if X is car on expressway, then again, if X is fast, then X is dangerous. Okay, so I hope you have got it. Next, there is some fast car on expressway which is dangerous. There is. So that means what? Or rather, there is some fast car. So there exists X. So now immediately I have told you I am talking about I have a bigger domain and I am talking about smaller domain. I will simply write AND. So now there is no confusion. Here there was confusion. P implies Q implies R. There was a confusion. But in case of AND, we do not have any kind of confusion. I will blindly write it. CX and FX and DX. No need to apply bracket and all because AND is associative. That's it. So this was very simple question. So there exists X. So something in this universe, some X in this universe, if X is a car on expressway and it is fast, then and it is dangerous. Are you getting it now? Something in this universe, if some X in there should be some X in the universe, and it should be car on the expressway, and it should be fast, and it should be dangerous. Same thing, na? There is some fast car on expressway which is dangerous. I think you have got it. Next, if anybody is having any doubt, please let me know. Next, some car on expressway is fast and dangerous. Some car on expressway is fast and dangerous. So what should be done now? So try to focus here. There is some fast car on expressway which is dangerous, and some car on expressway is fast and dangerous. Both are one and the same thing. So same answer. Okay, please try to, if you have any doubt, then that means you have English problem. So you have to correct your English if you have any doubt here. So please try to find the meaning. Some car on expressway is fast and dangerous. So there is some car on the expressway which is fast and dangerous. So same thing. There is some fast car on expressway which is dangerous. One and the same thing only. Please take snapshot. I will jump to the next slide. Okay, I am jumping now. Yes, so now I can pick up the speed. I think you have got your basics clear. Domain, all objects in the storeroom. BX, X is bicycle, RX, X is red. So domain is what? All objects in the storeroom. So I'm talking about every object in the storeroom. And BX is what? X is bicycle. RX means X is red. So every bicycle in storeroom is red. Every means what? For all X. So every bicycle in storeroom is red. So everything in this in the storeroom, if X is bicycle, every X in the storeroom, if X is bicycle, then it should be red. So simple. Next, every red thing in the storeroom is bicycle. So every red thing. So every X for if every X in the storeroom, if X is red, then it should be bicycle. Okay, so first question is saying, see, both are not equivalent. Clearly they are not equivalent. I have told you many times, P implies Q, Q implies P. They are not equivalent thing. So what this is saying, every bicycle in storeroom is red. So this conclusion of this is no blue bicycle. No blue bicycle. We cannot have any blue bicycle because every bicycle is red. So I cannot have blue bicycle. And what this is saying, every red thing in storeroom is bicycle. That means I cannot have red car in the storeroom. Red car not allowed, or red carpet not allowed. So every red thing is bicycle. I think you have got it. Both are clearly different thing. Next, some bicycle in storeroom is red. So there exists X. So something in the storeroom is bicycle and it is red also. Something in storeroom is bicycle and it is red also. Yes. So fourth question. Everything in storeroom is red bicycle. This is very, very important. Everything in storeroom is red bicycle. That means what? Whatever you are talking about in the storeroom, it is nothing but your red bicycles only. So you have a, I think you can imagine that you have a shop of bicycle, and in your shop you have all the bicycles are red. So that means what? Everything. Rather, I should say like this. I should not say all the bicycles are red. I should say in your shop, whatever thing you see, it should be a red bicycle. So nothing is there in the storeroom except the red bicycles. Okay, so so you cannot have any blue bicycle, or you cannot have any red carpet. You cannot have anything other than your red bicycles. I think you have got it. Now everything is this red bicycles only. So now I think you have got it. For all X, BX and RX. So I have told you, na, for all X, with for all X sometimes and is meaningful. So here I have told you, here it is meaningful. For all X, BX and RX. Okay, everything in the storeroom is red bicycle. I think you have got it. Please take snapshot. I will jump to the next slide now. You have to do a lot of practice. Only then you will be able to solve with fluency all these kinds of questions. Okay, I'm jumping to the next slide now. Please take snapshot. Okay. Next is domain is all objects in the room. Rx, X is red bicycle. Bx, X is ball. Bo, X is bouncing. All objects in the room. Rx is X is red. Bx, X is ball. Bo, X is bouncing. There is red bouncing ball in the room. So in the room there is a red ball which is bouncing. This is the case. There is. So there exists X. Something in this room. It is red and it is ball and it is bouncing also. I think you have got it. Something in the room is red and it is ball and it is bouncing. So there is red bouncing ball in the room. I think you have got it. Please take snapshot. I will jump to the next slide now. So you need experience. You need a lot of experience to solve this kind of question. And by experience, I mean practice. You have to do a lot of practice. Okay, I'm jumping to the next slide. Every red ball in the room is bouncing. Every red ball in the room is bouncing. Every means for all X. But I will say if it is a red ball, then it should be bouncing now. So first of all, it should be a ball. Second thing, it should be a red. Then it should be bouncing. So every X in the room, if X is a ball and it is red, then it should be bouncing. So this is the meaning of every red ball in the room is bouncing. Next, every bouncing ball in the room is red. Same kind of thing. Every bouncing ball. So it should be ball and it should be bouncing. If it is a ball and it is bouncing, then it should be red. Every bouncing ball in the room is red. So there is a room and there are some balls which are bouncing here and there. So all the balls which are bouncing here and there in the room, they all should be red color. There should be no blue color ball and all. So this is the meaning. For all X, Bx and Box implies Rx. X should be ball, X should be bouncing. X is a ball and it should be bouncing. Then it should be red. I think you have got it. Please take snapshot. I will jump to the next slide now. Okay, I'm jumping now. Yes. So now see this. There are two questions. Please let me know are they equivalent or not. First is no hardworking person is poor. Second is every hardworking person is rich. Are they equivalent? What do you mean by this thing? No hardworking person is poor. So if you think carefully by common sense or by English, you may be able to think no hardworking person is poor. That means if you are hardworking, you are not poor. That means what? You are rich. So that means what? Every hardworking person is rich. I think you have got it. They are equivalent. 100% they are correct. How I will prove it by logic? So there is a shortcut to prove all these things by logic. Let me tell you the shortcut. Whenever you see no hardworking like this, no and something is there in the sentence, with no there is something in the sentence, you will write T and you will write A. Now you will try to expand it by logic, not a. First of all, a hardworking person is poor. A means there exists. HX means hardworking person is poor. There exists X, HX and PX. And not means like this. Are you getting it? So there is a shortcut to prove all these kinds of things. So no, and after no there is a sentence, big sentence. So you will apply T and A and then you will try to solve it. So hardworking person, a means there exists X. Hardworking, letter I am supposing it as HX, and poor X means PX. So there exists X, HX and PX. So a hardworking person is poor. So no means not, not means I will apply a not here. So I think you already know how to expand it. So whenever we have a not, so you will take it inside. So whenever I will take inside, there exists will become for all will become there exist. Okay, so I think you have got it now. They are complementary of each other. So whenever I will take not inside, this will become for all X and I will apply HX and PX not na HX and PX I will apply not here just to save the time. I want to give you the feeling of Boolean algebra so that you get more clarity. So I have applied here bar. So whenever I will solve the bar, what I will do for all x, so I will say either not hx or not px. Are you getting it now? By De Morgan's law, I have expanded it. Okay. So for all x, not hx or not px. Let me write it properly. Yes. So are you getting it now? There is first of all, hardworking person is poor. A hardworking person is poor. So there exists x, hx, and px. I have told you many times. There exists means and will be meaningful. Not means I have applied not. So whenever I will take not inside, there exists will become for all. For all x, hx, and px, and there will be bar over it. Whole note was there, na? So note will be there. So I have applied here bar. One and the same thing. So I will apply De Morgan's law and I will get this thing. So now what I will say, for all x, not of hx or see not px, I can not poor means what? Rich, rx. So I will write it as rx. So not p or q, are you able to remember? P, not p or q, that was nothing but p implication to q. So what I will say, for all x, hx, for all x, hx implies rx. So every you can say every person, if every hard working person is rich, I think you have got it. Every hard working person is rich. Okay, so I think you have got the idea. So these two are equivalent sentences. By common sense we have got it, but if you have any doubt, I have explained it by logic. This is the way to prove. If somebody say you prove these two sentences are equivalent, you will do like this. This is the derivation. Next, not all hardworking persons are poor, or some hardworking person are rich. So please try to expand it. Not or first of all this thing. All hardworking persons are poor. For all x, hx implies px. Not means like this. So I will take not inside. So there exists x, and hx implies px. Not means what? Hx bar plus px whole bar. I think you have got it. Not I have taken inside, so I have expanded it. Not hx plus px. Yes. So what I will say, there exists x. So I will apply De Morgan's law, change the sign, break the line. So what I will get, hx and px. Not means what? Rx. Na? Not poor means what? Rich. So hx and rx. Hx and rx. Okay, so what do you mean by this? There exists x, hx and rx. That means what? There is some hardworking persons are rich. Same thing. Some hardworking persons are rich. So they are also equivalent. So question number 1 is also correct. Question number 2 is also correct. I think you have got it. Please take snapshot or something. I will jump to the next slide. If you are feeling any kind of difficulty, please let me know. If you are not able to visualize, please let me know. I will try to explain it again and again till you get comfortable. Yes. Anybody is having any doubt here?
No, sir. No, sir. We need
Okay. Okay.
practice, sir.
Okay. Okay. So I am jumping to the next slide now. So same lecture. Try to see the same lecture again and again, and try to write all these things by your own. If you are able to write them, it's okay.
Yes, sir.
Okay, then I am jumping to the next slide. These things are no doubt hard, but no problem. Do practice, you will get it. Okay, next. Diamond and pearls are precious. This is a gate question, by the way. I do not remember the year. This is a gate question. Diamond and pearls are precious. This is the sentence, and they are saying dx is x is diamond, px is x is pearl, prx is x is precious. This is given. So what do you think? A option and B option. So diamonds and pearls are precious. That means what? This is a generalized sentence. Na? That means what? Every diamond and pearl is precious. Are you getting it? Diamonds and pearls are precious means what? Diamonds and pearls are precious. That means what? Every diamond and pearl is precious. Na? Are you getting it? This is a plural sentence. Na? Whenever we have plural, that means what? I am generalizing the things. Like I say, birds fly. What do you mean by this? Birds fly. That means what? Every bird fly. Are you getting it? If I write birds fly, this is generalized statement. you will say every bird fly. Every bird fly. Okay, yes. So diamonds and pearls are precious. That means what? Every diamond and pearl is precious. So now I think you have got it. For all x, dx and px implies prx. Most of the students will take this thing, and rather 99.9% student in gate will take this thing. For all x, dx and px implies prx. But if you have studied carefully and if you have listened my words, each and every word carefully, then I think you have got it. What do you mean by this? For all x, that means what? Everything in the, see, domain is not given to us, so domain will be entire universe. Domain will be entire universe. So everything, for every x in the universe, if x, you have to see, this is the universe. So everything, every x in the universe. So if you taken this as x, now you are saying x is diamond as well as pearl. This is completely meaningless thing. How can the same object be diamond as well as pearl? That is not possible. So obviously this statement is meaningless, completely meaningless. So I should say like this. I am saying that diamonds and pearls are precious. So now in the universe, you will pick the object and you will say, is it diamond or pearl? You will think like this. Now, is it diamond or pearl? If it is diamond or pearl, you will say, okay, it is a precious thing. Are you getting it? Please try to focus here. Please try to dig deep into the topic. What I'm saying, you know nothing about, you know nothing. You just pick anything in the universe. And now you will say, is the thing in your hand diamond or pearl? Then you will say, okay, it is precious. And what first statement is saying? You pick something in your hand and you are saying, this is diamond as well as pearl. This is meaningless thing, na? How can something be diamond as well as pearl? So now I think you have got it. This B option is correct. So this is the kind of twist which GATE exam will give. They want to check how exactly you know the things. No doubt there is and here, and everybody think because of this and we have to take this and. But no, here the meaning of and is coming to be or. So every object in this, every x in the universe, if x is diamond or pearl, then it should be precious. This is 100% correct. Okay, so these kind of twist you will face in GATE exam. Many times these kinds of twists have been asked. Okay, please take snapshot. I will jump to the next slide.
Yeah, sir.
Okay, I am jumping now. Next, this is GATE 2006 question. So what it is saying, which one of the first order predicate calculus statements given below correctly expresses the English sentence, tigers and lions attack if they are hungry or threatened? Okay, so how you will expand it? So first of all, if na p if q, try to give me the idea. P if q, I have told you it is like this. Okay, so p if q is like this. That means what? It is nothing but your q implies p like this. If p then q, that means p implies q. But p if q means q implies p. I have told you many times. These things GATE exam has asked many times. Okay, now if you are comfortable with this thing, you will be able to solve this kind of question. So what first is saying? Let me expand each and every option. Then you will get more clarity. What first option is saying? Every x in this universe. See, domain is not given, so obviously I will take it as universe. So every x in this universe, if x is tiger and lion, you will immediately cut this option. See the previous explanation. So every x in this, you just pick anything in the universe. This is the universe, and you pick anything. You are saying it is tiger also and lion also. That is meaningless thing. A option is gone. B option. Every x in this universe, if it is tiger or lion, is it okay? It's okay now. It is tiger or lion. Then if it is hungry or threatened, and it will attack. So what it is saying, every X in this universe, if X is lion or tiger, then if it is then they are not saying if it is hungry or threatened, then they are saying if every X in this universe is lion or tiger, then it is hungry or threatened and it will attack. Are you getting it? What it is saying, B option. Let me write it, then you will get more clarity. Otherwise I will keep on speaking, you will not get the thing. Every X in universe, for every X in the universe, if X is tiger or lion, then it is hungry or threatened and it will attack. So are you getting it? For every X in the universe, if X is tiger or lion, if X is tiger or lion, then see this na, if this then this na. So if X is tiger or lion, then it is hungry or threatened and it will attack. So that, what do you mean by this? Every lion or tiger is hungry or threatened. So every lion or tiger in the universe is hungry or threatened and it will attack. It is meaningless thing na. So that means what? Every lion or tiger is hungry or threatened. Every tiger. So you just pick every tiger or lion. You just pick any tiger or lion. Either it is hungry or threatened, and it will definitely attack you. So directly and indirectly it means that whenever you see lion or tiger, it will be definitely hungry or threatened, and it will definitely attack you. Obviously it is meaningless. They are saying like this: tiger and lion attack if they are hungry or threatened. That means if the tiger or lion is hungry or threatened, then it will attack na. Normally lion or tiger do not attack. When it will attack, when it is hungry or threatened, then it will attack. Otherwise it will not attack you. But what it is saying, every lion or tiger is hungry or threatened and it will attack you. It is clearly a meaningless thing. B is wrong option. Okay, let us track the C option, and please try to figure out the brackets here. Okay, you should not get confused. So this entire part you take it as P implies, and this entire part is taken as this is say Q and R, like this. P and Q imply P implies Q and R. This is the thing. So if it is lion or tiger, then it is hungry or threatened and it will attack. Are you getting it now? This entire thing is Q and you just take it as R. Please try to see the brackets, you will get more clarity. This is the bracket, this is the bracket. So in this bracket you are saying, so this is the Q. If you have doubt, let me write it. P implies this entire part is Q and this part is R, and like this. So here we have a bracket. So that's why I have taken if P then Q and R na. If P then Q and R. So if P means what? If it is lion or tiger, then it will be hungry or threatened and it will attack you. I think you have got it now. It is really simple thing. Now let us see the C option. What C option is saying, for all X, that means for every X in the universe, if X is tiger or lion, then if it attacks, then it is hungry or threatened. Let me write the C option. What C option is saying? For every X in universe, if X is lion or tiger, then if it attacks, then it is hungry or threatened. See, these are really very, very beautiful things. Okay, I am smiling because they have very, very deep meaning if you try to understand. Okay, so let me write it properly. Hungry or threatened. What do you mean by this sentence? C option is saying for every X in the universe, if X is lion or tiger, that means if it is lion or tiger, then if it attacks, then this means it is hungry or threatened. C option is saying if you find a lion or tiger and it attacks you, then it means it is hungry or threatened. C option is saying like this. And what we want, tiger and lions attack if they are hungry or threatened. That means what? If they are hungry or threatened, then they will attack you. And what you are saying, what C option is saying, C is saying if it attacks you, then this means it is hungry or threatened. So obviously C option is wrong. So the last option, obviously D is correct here. D is correct here. So now let me write it properly. What it is saying, every X in this universe, every X in universe, if X is lion or tiger, then if it is hungry or threatened, then it will attack. Please see this. Every X in this universe, if X is lion or tiger, then see this. Now if this, now see this, P implies Q implies R. This is the thing. Now P, this entire thing is P, this entire thing is Q, this is R, and here we have brackets like this. So Q implies R is in the bracket. So now see this, every X in this universe, if X is lion or tiger, if X is lion or tiger, then you have to solve this thing. Now you have solved this. If X is lion or tiger, then now I will come and expand it. If X is lion or tiger, then if it is hungry or threatened, then it will attack you. Same is the scenario. Every X in this universe, if X is lion or tiger, then if it is hungry or threatened, then it will attack you. Same is the statement which is saying tiger and lion attack if they are hungry or threatened. That means what? If they are hungry or threatened, if lion or tiger are hungry or threatened, they will attack you. I think you have got it. Okay. Yes. So anyway, I do not have much time here because there is a limitation of time. If you want to dig deep into all these topics, then you can watch my YouTube lectures. You will get more very crystal clarity in all these kinds of things. Okay. Anyway, if you want to dig deep, that's if you want to dig deep, then you refer that. Otherwise, no need. Otherwise, you have got it.
Sir, to face gate, you're supposed to go in detail, isn't it?
Please come again.
Is there a choice for us that whether we need to go in detail, we need to dig deep? Is there a choice? I'm asking you, is there a choice? Like we have to do it, isn't it? Suppose if you are very serious about your exam and want to crack, you have to dig deep. Is it not?
Yeah, you can. Yeah, you can think like that, but actually,
when you say that, sir, even on that day, I asked you. It lacks motivation.
Okay, so I should say like this: if you are able to solve PYQ, then no need. You are good to go. If you are not able to solve PYQ, then you can watch those lectures also. Okay, it's just like that. Now, if you have attended lectures of any teacher and you are able to solve gate question, then it's okay. Otherwise, you have to refer the standard books. So my lectures are standard book kind of thing. Okay. So yeah. So if you are able to solve all the PYQs, it's okay. It's really fine. But still, if you are not able to follow, then you can watch lectures.
All right, sir.
Okay, then I will jump to the next slide. Please take snapshot. So I think everybody have got this question now. If anybody is having any doubt, please let me know. I will explain it again and again. No problem.
Understood, sir.
Okay, then I am jumping to the next slide. Yes. So next is this is again a gate question. I do not remember the year. Purple mushroom are poisonous. This is the statement. So Px is X is purple, Mx is X is mushroom, Pox is X is poisonous. So I want to check these three options. So what it is saying, everything in the every X in this universe, if X is purple and it is mushroom, then it is poisonous. Obviously it is correct. Every X in this universe, if X is purple and X is mushroom, then it should be poisonous. Obviously it is correct. Next, every X in this universe, if X is purple, then if X is mushroom, then it should be poisonous. Obviously this is also correct. Next, every X in this universe, if X is mushroom, then if it is poisonous, then it should be, sorry, everything in this universe, if X is mushroom, then if X is purple, then it should be poisonous. Obviously this is also correct. So now my observation is that P implies Q implies R. This can be changed as P and Q implies R. You can check it out yourself. These two are equivalent thing. By Boolean algebra, you can solve it very, very easily. If you want me to solve, I will just solve it like this: P bar plus Q bar plus R, like this. This is the thing for this. And what about this scenario? I think you have got it now. P Q whole bar plus R, that is nothing but P bar plus Q bar plus my R. So in 1 second I have proved this thing. So P implies Q implies R, that is same as P and Q implies R. Okay, and now see carefully. P implies Q implies R is same as this thing. Now P and Q implies R will be same as Q and P implies R, because and is commutative. So now P implies Q implies R can be changed to this. So obviously Q implies P implies R can be changed to Q implies P implies R. This is very, very beautiful thing. You should remember this. Okay, so P implies Q implies R can be changed as Q implies P implies R. You may be thinking that they are not equivalent, but they are equivalent. I have proved that indirectly. And if you want to prove directly, you will immediately say, you just change it, Q bar plus my P bar plus my R. I think you have got it. P implies R is what? P bar plus my R. And so Q bar implies Q bar plus P bar plus R. And obviously we have got this also. So P implies Q implies R is same as Q implies P implies R, and it is same as P and Q implies R. Okay, so all the three options are correct. This is MSQ. If you remember this property, you can immediately answer that all the three are correct. But if you do not remember the property, you just apply the logic. Immediately you will say every X in this universe, if X is purple and X is mushroom, then it is poisonous. Okay, so now this here and is meaningful. Why and is meaningful? Because if you have picked any object in the universe and you are thinking that it is purple as well as it is mushroom, then you will think. But there was here diamond and pearl. Huh? So you just pick anything and you are saying it is diamond as well as pearl. No, it is meaningless thing. Okay, but here it is perfect. Purple as well as mushroom. Okay, so I hope I have made the point clear. So please take snapshot of this thing and I will jump to the next slide now. Okay, I'm jumping now. Fxy is x plus x and y are friends. Domain is all students in the college. So what are these? Okay, so now new kind of questions are coming. So on two variables now we are saying fxy is x and y are friends. Domain is all students in the college. So now domain is given to you. It is not entire universe, it is all students in the college. What do you mean by this? For all x, for all y, fxy. So every student in the college is friendly with every other student in the college. You can think like that. Okay, so every student in the college, every student in college is friendly with every other student in the college. Directly, indirectly, you want to say, you just pick any pair of student in the college, you will say they are friends. Okay, so this means pick any pair of student or pick any two student, pick any two students and they will be friend. That is the meaning here. You just pick any two students randomly. Randomly you pick any two students, you will say they are friend. What do you mean by this? For all x there exists y fxy. Every student in the college is friendly with at least one student. So that means every student in the college has at least one friend in the college. Okay, every student in college has at least one friend. At least one friend. If I write like this, then it is meaningless. At least one friend. So that friend may or may not be in the college. Okay, that friend may be somewhere else. So you should say every student in the college has at least one friend in college. Okay, in the same college. I should say like this. In the same college. Okay, so please try to understand these things. Next, there exists y for all fxy. So what do you mean by this? There is some student in the college which is friendly with all the students in the college. Okay, or there is a student in the college whose friend is entire college, whose friend is all the students in the college. Okay, you can think like that. So what should I say? Some student, I should say like this, some student in the college, some student in college has all students, yeah, is friendly with all the students in college. Some student in college is friendly with all students in college. Or you can think some student in college has entire college as his friend. Entire college has his friend as his friend. Okay. Some student in college has entire college as his friend. You can think like that. Next, anyway, is English is really very vast. So it's your wish how you make the sentence. It's your wish. Okay. Yes. So what do you mean by this? There exists x, there exists y, fxy. So some student in college has some student as a friend in the college. Okay, so it's your wish whatever way you want. So I want to say there is a pair of student which are friend. Some pair of student which are friend, or you just pick two student. So if you keep on picking two students, then you should pick at least one pair which is friend. Are you getting it now? So these are the students in your college. So I will say there is at least one pair which is friend. Okay, so it means, so some student in college, some student in college is friendly with some other student in college, is friendly with, rather I should say like this only, some student in college. Okay, some student in college is friendly with some student in college. That's it. Okay, this is the way. So if you have any doubt, please let me know. I will try to explain it again and again, and please try to make your English sentences. These are my way. You can make your way to make English sentence. Okay, and if by chance I will teach another batch, I will use some other English sentences, because I do not remember what English sentences I have used and all these kinds of thing. But the thing is that they should be correct. That's it. Okay, so it's your wish how you make them. And by the way, in gate exam you will find the options. From options you can make the sense. The only thing is, if you have more precise or more good English, you will be able to answer such question more easily. But if your English is not good, then God can help you in gate exam for such kind of questions. Okay, because I have seen many students in my experience that their English is not good, and just because their English is not good, they are not able to solve such kind of questions, because they will certainly feel some kind of difficulty in understanding the things and all. Okay, so your English should be quite good to answer such questions, because as soon as you read the sentence, you should be able to understand its meaning very precisely. Okay, so please take snapshot. I am jumping to next slide. Yes, I am jumping now. Next is VXY. VXY is X has visited website Y. Okay, VXY means X has visited website Y. So now you can see fxy was x and y are friends. So fxy and fyx both were same. fxy and fyx both were same previously. In the previous question, both were same because I was just saying x and y are friends. So that means what, y and x are also friends. See, you have just picked two students, x and y are friends. So obviously, I will say this is x and this is y. X and y are friends. So I can say y and x are also friends. One and the same thing only. But this is different. vxy means x has visited website y. So now vyx means y has visited website x. So directly indirectly, x is some student or something and y is the website. Are you getting it now? And domain x is all students in the college. Domain of y is all websites. Are you getting it? Domain of x. Now different domains are given. Domain of x is all students in the college. So x is student in the college and y is websites. All the websites in your internet. Okay. So x has visited website y. And what do you mean by this? Y has visited x. Okay. So I think you have got it. The first one is student and second one is website. So clearly they are not equivalent. Okay, now try to answer these questions. What do you mean by this thing? For all x, for all y, vxy. Every student in the college has visited every website. Every student in the college has visited every website. Every student in college has visited every website. Has visited every website. What do you mean by this? Every student in the college has visited at least one website. Okay, let me copy it. Every student in the college has visited at least one website. Has visited at least one website. I think you have got it. Next, what do you mean by this? There exists y for all x. What do you mean by this? This means what? There is some website. Y domain of y is all the website. Domain of x is all the student. So there is some website which has been visited by all the students in the college. So there is some website like in the college, I think Facebook is very famous. So Facebook is a website which has been visited by every student in the college. This is the meaning. So there is some website or some website, I should say like this, some website has been visited, some website has been visited by all the students in college. What do you mean by this? So some student has visited some website in the college. Okay, some student of college, some student in college has visited some website. Some student in college has visited some website. Okay, so that means there is some student in the college who has knowledge of internet. You can think like that. Okay, because he has visited some website. So that means what, in the college there will be many students. Okay, and I want to say there is some student in the college who knows the internet. You can think like that. Okay, so some student in college has visited some website. That is the meaning. What do you mean by this? Every website has been visited by at least one student. Every website has been visited by at least one student. Are you able to get it? Every website. So there are lots and lots of websites in the internet, and each and every website has been visited by at least one student. So there is no website which has not been visited by any of the students. Okay, you can think like that. No website is there in the entire internet which has not been visited by any of the student in the college. So that means what? Every website has been visited by some student in the college. Every website has been visited by some student in college. Next, some student in college has visited all the website. So there is some internet freak in your college. Student in college. Some student in college has visited all the websites. Okay. Some student in college has visited all the websites. Okay. So I hope I have made the point clear. You can take snapshot. Okay, I'm jumping now. So what do you mean by this statement? Some boys are taller than all the girls in the class. Please try to focus here. Some boys are taller than all the girls in the class. All the girls. Okay, so these are the girls in the class, and this is one boy who is taller than all the girls in the class, and there may be some other boy who is taller than all the girls in the class. That is the meaning. Xy means x is taller than y. So if you write like this, what do you mean by this? Now please try to concentrate. Many of you will get confused here, and you will say x is what? Some y is taller than every girl in the class. Like this you will say, but it is meaningless. Why? Domain is not given. When domain is not given, you will say something in this universe is taller than everything in this universe. Clearly this is meaningless thing. Okay, this is meaningless thing. So since domain is not given, if domain was given, then it may become meaningful also. But domain is not given, so universe is there. So you will say something in this universe is taller than every other thing in the universe. Clearly it is wrong. Now try to concentrate here. So what I will say, there exists x in the, so some x in this universe. If x is a boy, sorry, some x, or I should say, see, this is the universe. So there exists, or there is some x in the universe. X is a such that there exists x or some x in this universe such that x is a boy, and for all y, gy means what? Every, for all y means every other object in the universe. If that y is a girl, then x should be taller than y. So this is the meaning. This is perfectly fine. So meaning of this is this. This is correct. Let me read it again. Something in this universe, if or some x in this universe, there is some x in the universe such that x is a boy, and for all y, that means for every other element, or everything in this universe, if this y or every y in the universe, if y is a girl, then x should be taller than y. Okay, now let me see this. What do you mean by this thing? For all x, I am asking the question, are they two equivalent? So there exists x for all y. Now I think you have got it. Now see, I can take this for all y outside also, because this is x, this is bx. So bx will not get hampered if I take for all y outside. So I will take comfortably this outside. I will say there exists x for all y bx, and gy implies txy. Okay, so see, some of you might get confused, so I should write it, but I should say some x in this universe. So there is some x in the universe, or there exists, or there is some x in this universe, such that x is boy in the class, and and if for every y in this universe, and if or actually you will get confused if I will keep on writing universe and all. I will say and every girl in this, and every girl in the class, every girl in the class, mm, there is some X in the universe such that X is a boy in the class, and if Y is a girl in the class, and if Y is girl in the class, then X is taller than Y. I think you have gotten what is Y.
It's not
Y is
for all
anything
the
in the
girls in the
universe.
class.
Yeah, come again.
It's for all the girls in the class, right?
Yes, yes, yes. For all Y. For all, see, I have written for all Y. Domain is not given, so I will say Y is universe.
And
Y
if
is any
Y
object in the
is
universe.
uh-huh. And in the English statement, sir, what you mentioned now,
Hmm.
there's some X in the universe
Hmm.
such that X is
Hmm.
boy in
Hmm.
class,
Hmm. Hmm. Yes. X is boy
and
in
if
class. Yes.
Y is a girl,
Huh.
all the Y is a girl in the class, all
Hmm.
the girls in the class, no, sir. Y is a
Huh.
girl.
If Y is girl, if Y, so what is Y? I have told you, na. Y is anything in the universe.
Okay, then how do we make it know that Kate is like for all? What will be the
Because here
supposition?
we have for all. Na. So if Y is girl, anything in this universe, if anything in this universe is girl in the class, then X is taller than Y, na.
So in the whole of the sentence, where do we have for all?
We do not have for all, but try to understand the meaning.
Okay, no.
There is some X in this universe
Yes.
such that X is a Y in the class, and if Y is girl, what is Y? Y is anything in the universe. So now if Y is a girl in the class, then X is taller than the Y, na. So you keep on picking the Y. If you think that Y is a girl, then you will say X is taller than Y. Then again you pick any Y, you will say X is taller than Y. Again you pick any Y, you will say X is taller than Y. You will keep on thinking like this.
What
So
I
for
now
all is
did,
implicit in here.
I tried writing this expression for English
Hmm.
sentence what you wrote, sir. There I
Hmm.
was missing for all to specify the girls, the total count of girls, all.
Hmm.
Because I was like, X is boy in class, and if Y is girl, so I was
Hmm.
getting a sense of a singular there. So
Okay, okay. But it is
that's it.
not similar. I think you have got it. Now, if you have doubt, then I will explain
I
it again.
I understood, so I understood with
Hmm.
contrast to the expression which has already been seen by us. Only if I look
Hmm.
at the English sentence, I'm not able to make the expression.
Yeah, 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 yeah. That is the power of logic, na. If you just see the English, that's why we say English is an ambiguous language.
Okay,
That's why
sir.
logic was invented, and that's
But
why
we have got some
it is.
questions in which where they give in English and we are supposed to write expression.
Hmm.
Do,
Yeah, yeah.
do we get then in that case like
Same question I have given you, na. Some
yes,
boys
yes.
are taller than all the girls in the class, so you have to write it in logic.
Here we have got all the girls in the class now. So can we just enhance this statement also with all somewhere?
This statement.
Yeah, yeah, sir.
Okay, so this statement will become this
Yeah.
only. Some boys are taller than all the girls in the class only.
Okay, sir.
Okay, so if you want see the meaning English, otherwise English sentence will break. Na, grammar will break. If I try to if you insist me to somewhere fit for all here, then English will be broken. Grammar will be broken. So there is some. Let me try it. There is some X in the universe such that X is boy in the class, and if no,
Why are girls in the class? Why are girls in the class?
if Y are girls in the class, then X is taller than Y. If Y
Yes,
are all the girls in the class, if
yes, sir.
Y
Yes,
are
sir.
all the girls, you can think
Yes,
like that.
sir. Yes, sir.
Okay. Yes.
Yes.
So yes. So and these are equivalent. I have told you.
Hmm.
Okay, so please take snapshot. I will jump to the next slide now. Anyway, please do not think that these things are difficult. It's just like that because I'm just keep on speaking, and you are just listening all this kind of thing. If you try to apply brain, and if you try to think about it, once you have taken my lecture. Now, if you see the recording, then my suggestion is you please pause the solution what I have given you. Okay, once you do like this, everything will fit in your mind in very crystal clear way. I have explained very beautifully all the points, so you will not get confused anywhere.
No
Okay.
doubt, sir. Yes, sir.
Okay. Okay, then I am jumping to the next slide now. Yes, for all x is not equal to 0 implies there exists y, xy is equal to 1. Domain is all the real numbers. Now mathematics has come into the picture. This is also a gate question. So we will try to answer it. For all x is not equal to 0. What do you mean? And domain is real number. Every real number. For every real number, if it is not 0, that means for every non-zero real number. Every non-zero real number. There exists y, xy is equal to 1. First of all, please tell me xy is equal to 1 means what? Xy is equal to 1 means what? X is equal to 1 by y. So I will say x is multiplicative inverse. This is the basic mathematics terminology. X is multiplicative inverse of y. And you will similarly say like this also. Y is multiplicative inverse of x. Y is multiplicative inverse of x. One and the same thing. Obviously, when x is multiplicative inverse of y, then y will be multiplicative inverse of x, because xy is equal to 1, x is equal to 1 by y. So you will obviously say y is equal to 1 by x. One and the same thing only. Okay. And by the way, just for the sake of knowledge, I am telling you x plus y is equal to 0. So you will say what? X is equal to minus y, or you will say y is equal to minus x. So in that scenario, you will say x is additive inverse of y. X is additive inverse of y. This is the mathematics terminology. And similarly, you can say like this also. When x is additive inverse of y, then obviously y is additive inverse of x. Just for the sake of knowledge, I have told you. So here finally what we will say, x is multiplicative inverse of y, and y is multiplicative inverse of x. So see this, for all x is not equal to 0 implies if x is not equal to 0, then there exists y such that xy is equal to 1. So that means what? There exists y is what? Multiplicative inverse of x. So every non-zero real number has multiplicative inverse. As multiplicative inverse. Please let me know if anybody is having any doubt. Every non-zero real number has multiplicative inverse. This is the meaning of this logic sentence. Every non-zero. Why I'm saying real number? Because domain is set to real number. So every non-zero real number has multiplicative inverse. Yes. Any doubt?
Understood, sir.
Okay. Yes. So let me see the time. Only 1 minute is left. So should I solve this question? Yes. Should I solve it? Okay. It will take just 1 minute. Or should I keep it as homework for you? You will try it. It's better option.
Yes, sir.
I'm keeping it as homework. Please try yourself. Okay. And then we will discuss this in the next class. And I think one more question is there. Again, I'm giving you as a homework for you. This is also MSQ. Yeah, you can take screenshot. Please take screenshot of this. Try to answer this question. So now here the question is px. What is px? Try to explain it in English. What is px? So px is equal to this thing, na? So this is the logic formula. This is the logic formula which is given, and px is this. So they are asking what is px, and domain is positive integers. I hope you have taken the snapshot and see this. This is very, very beautiful question. Take it as homework. I will explain it in the next class.
Yes, sir.
Yeah. So that's it. So logic is over now. Only 2 questions are left. In the next class, we will complete the logic and we will jump to the combinatorics. The next topic in the discrete mathematics, combinatorics, we will start in the next class itself. Okay,
Yes, sir.
and please bring your doubts and all regarding logic. Okay, you can ask me. You try to solve pyqs, and please watch this lecture again and again. Okay, it's my first preference should be watch this lecture, recording of this lecture again and again till you understand it, and then try to solve all the pyqs. If you are not able to solve the pyq, then in the worst case you will refer my YouTube videos.
Okay,
Okay,
sir.
yeah. Okay then, thank you so much. Bye bye.
Good answer.
Good night.